Hello, everyone, and thank you for joining us. We're going to wait a few minutes, let a couple other folks join. We'll be getting started here shortly. Hello, everyone, and thank you very much for joining us here today. We've got a reasonable number of folks on the line, so we're going to go get started. Well, I'm sure we'll have other folks join in the next few minutes. My name is Brian Adler, and as you can see here, I'm the Senior Director of Cloud Market Strategy here at Flexera, joined by my good friend Sean Pomeroy. Sean, say hi to the nice folks out there.
Hi, all. Thanks all for joining today. So, Sean Pomeroy, I'm a Senior Solution Engineer here at Kubecost.
All right, thanks, Sean. So hopefully all here for the right reason, right? We're here to talk about, as you can see, simplifying the complexities of Kubernetes spend as it relates to your cloud cost journey. And in particular, we're going to spend some time, I'll get into agenda here in just a moment. We'll spend a significant amount of time. Sean will be giving a demo of the integration of Kubecost solution with Flexera One's CCO, or Cloud Cost Optimization, part of the Flexera One platform. So with that said, let me go ahead and we'll jump through the agenda. We're going to do a little sort of level setting, if you will, before we get into the meat and potatoes, if you will, which will be Sean's demo here. First, we'll do a quick introduction of both Flexera and Kubecost for those of you that might not be familiar with one or both of us. I'll then spend a little bit of time talking about cloud consumption trends that we've seen over the last 11 years, and I'll talk about where that number 11 comes from in just a moment when we start to get to some of these slides. Then we'll jump into some of the common cloud cost challenges that are resulting from those cloud consumption trends. Sean will talk a little bit about some of the Kubernetes-specific ones. As you get sort of, every level deeper into the tech stack, the water gets a little murkier, if you will, and those challenges get a little bit different and more nuanced. And then, as I mentioned, we'll get into the demo, and Sean will give a demo of that integrated solution between Flexera and Kubecost. We'll then do a quick summary and hopefully have some time for some Q&A. And speaking of Q&A, hopefully you all noticed in the On24 platform, there's a little Q&A panel, you can pop open. Feel free to enter any questions that you have during the webinar. Sean and I are going to wait and answer those all at the end, just to make sure that we get through, the full demo and things like that. Whatever time we have left over at the end, EJ, who's running things in the background here for us, will go ahead and read any questions that have come in, and Sean and I will do our best to answer those for y'all. Okay, so with that said, quick introduction. I'll do the left side, and I'll kick it over here to Sean in a moment for the right side. So Flexera, who are we? Well, Flexera, as the words here say, right, enables organizations to maximize their technology investments from on-premises, right? You have on-premises software, to SaaS. We have a SaaS management platform. To cloud, we have a cloud management platform, as well as our cloud cost optimization, or CCO solution, and all the way through containers, both through our own support as well as the extended support that Kubecost adds to us. Now, Flexera we use the letters TVO, Technology Value Optimization, and that's really what we're all about. We're helping companies optimize the value that they get out of their technology investment. So with that said, I'll pass it over to Sean to do his side.
Yeah, thanks, Brian. So Kubecost is based on an open source container model. A similar concept to what Flexera is doing, but primary focus is Kubernetes. So we're providing a comprehensive cost monitoring optimization solution specifically to teams running Kubernetes, whether it be in the cloud, at the edge, on-prem, or even in air-gapped environments, getting those cost metrics back to the teams so they can make informed decisions about how to size their containers, as well as the potential cost with running their applications in a microservices way.
Great. Thank you, Sean. So as I mentioned, we're going to go ahead and jump into some cloud consumption trends. So I'm going to show you a little bit of data. And here on the right side of the screen, the image that you see, the figure that you see, is from, as you can probably see in the very small print down the bottom, from the 2022 Flexera State of the Cloud report. If folks out there have heard of Flexera for only one reason, it's probably the State of the Cloud report. It was previously the RightScale State of the Cloud report, if that rings a bell to you all. RightScale was acquired by Flexera in 2018, and with that came the intellectual property of the State of the Cloud report as well. So if you're familiar with that report, this is a continuation of that. And this is the 11th year that we've been doing this report, and it's sort of become the industry de facto standard in terms of identifying trends in cloud computing, from strategies, challenges, initiatives, success metrics, all those types of things, from industries from the small to the tall. We talk to folks that are, startup shops all the way up to 10,000 and more employees to get their pulse on the things that they're concerned with, the things that they're working on within their cloud environments. And what you're going to see are a few snapshots that we've taken from that report. And I should mention, Sean, did you know that the 2022 Flexera State of the Cloud report came out just last week? Nope, Sean's probably on mute. I'm sure you probably did. Yeah,
yes. And thankfully, a good friend of mine forwarded it to me so I could read it ahead of time.
So I just want to let you know, the quick plug for Flexera out there, folks. If you want, you can go to flexera.com. There's a link, excuse me, on the main page to go ahead and download the entire report. There's about 74 figures and 95 pages, right, of really, really in-depth detail. We're just going to scratch the surface here today. So speaking of the data, the first point to notice, 8% of all organizations, if you look at that all respondent column there in blue, 8% of all organizations annually spend $60 million or more on public cloud. That's $5 million a month. If you look at the enterprise, the purple layer in the middle, that jumps to 11%, right? 11% of companies with 1,000 or more folks are spending $5 million or more on public cloud. If you look there, it says 37% of enterprise organizations spend 12 million or more, right? So 1.2 million or more. 37%, over a third of them are spending that much money on public cloud at this point. And the most interesting one of this group here to me is this last one. The 53% of small to mid-sized businesses, those are businesses that have less than 1,000 employees, are spending more than $100,000 per month. And the reason that I find that one very interesting is that we didn't necessarily put it in this slide here, but last year, that number was 38%. We saw a 15% year-over-year gain of the small and mid-sized businesses that are spending $1.2 million a year or more on public cloud. So enterprises have been in there for a while now and spending more and more money, and we're really seeing more and more of these SMBs start to adopt public cloud and really start to consume the resources of public cloud. Now, with that comes problems, right? We'll talk about some of those problems here in a minute, but another trend that has remained over the last 11 years is waste is prominent. We always ask folks, we've asked folks in all 11 years, hey, what do you estimate is your wasted spend? What do you think? And it's funny that it's always right around 30%. That seems to be a comfortable number. Folks realize I'm probably wasting a lot, but I don't want to be too huge so it's overwhelming. So every year it's been between 29 to 33%. But the point being is that folks realize that, yes, I'm probably wasting a fairly significant amount of my cloud spend. And we back in the RightScale days when we first started doing the Optimal product, which then evolved into the Cloud Cost Optimization product, through the work with clients, we found that this was typically even, the waste was even higher. It wasn't uncommon to have 35, 40, even up to 50% waste, particularly for organizations that are new to public cloud. And the reason being is that I don't want to say they're doing things the wrong way, they're just not doing things the cloud way, right? They've done things the way they've always done before, and the cloud is different, right? You have to learn to, like your mom used to say, when you leave the room, turn off the light. Hey, when I'm done with this server, turn it off. Don't put more on your plate than you can eat, right? Don't take a 4-core VM if you only need a 1-core, those kinds of things. Use the discounts that are out there. So the way that you get better at cloud with cost optimization is through repetition, right, and experience. And that, obviously, you're new to the cloud and you're not going to see that. So as I said, we saw folks wasting up to 50%, particularly new organizations to the cloud, just because they didn't have things done the cloud way, if you will. And then where does that waste come from? Well, a variety of flavors. Big one is lack of visibility, and Sean will talk about that as well in his demo a bit, and how Kubecost really helps with that visibility. But you have a lack of visibility into what is being spent. Right? Maybe I get a bill from AWS at the end of the month for $1 million. Well, and there's 10,000 line items on this thing, and I have no idea to know who's spending what, right? Is cost center ABC doing the right thing? Is cost center, XYZ doing the wrong thing? I don't know. I don't know who's being efficient. I don't know who's being inefficient because I don't have that visibility into who's doing what and where they're doing it. Another one is that, put more on your plate than you need, as I mentioned, inefficient consumption of resources. And this is something that myself, I'll say, was guilty of. Back in the data center days, every 5 years, our boss would come along and say, hey, we're doing a tech refresh. What do you guys need for the next 5 years, right? This is your one shot. So, of course, we asked for the moon, and we got a bunch of stuff. And 6 months after that, I had a bunch of excess capacity. I was going to grow into it, but I had, 100 cores sitting next door that were idle. Well, I'm going to grab 4 of them to go ahead and do my app, even if I don't need 4, because we already paid for them. There's no downside. They're just sitting there, right? Well, in the cloud, that matters, right? You're going to pay for those 4 if you only need the 1. So again, those are behaviors that folks had when they were in the data center that they need to kind of relearn to get around that inefficient consumption of those resources. And then I mentioned a little about discounts, underutilizing commitments and pre-purchase options. That's another thing that's different about cloud. There's things, if you folks are familiar with the phrases savings plans in AWS, reserved instances, committed use discounts, Azure hybrid benefit if you're in Microsoft Azure, spot instance, low priority VMs. If you're not familiar with any of those terms, please research them. I would say, I'm going to get on my little soapbox here for just 30 seconds, I promise, but if you're an AWS customer of any usage level and you're not using an AWS savings plan, please look into them. They are brain dead simple way of saving money, and you're definitely leaving money on the table. So, all right, off my soapbox there for a second. Okay, so moving on, some more trends. This is where I'll kick it over to Sean, to let him talk about some of the stuff they've seen in the Kubernetes space.
Yeah, perfect, Brian. Appreciate it. Thank you. I don't think anyone's going to argue that Kubernetes adoption is exploding. The CNCF does a similar survey to kind of what Flexera does with regards to the state of the cloud. And this most recent survey, I think it's the 6th year that they're doing it. They say 96% of organizations are using or evaluating Kubernetes. I mean, that's enormous. And kind of the most surprising factor is that 73% of respondents are actually in emerging technology hubs like Africa. So the usage is actually exploding at an exponential rate. According to that survey, many of these customers are doing some cost monitoring today, whether it be homegrown tools or using some type of third-party solution. But a lot of them are actually leaving out a lot of important details, like the ability to inspect usage, all the way down to the container level to see like how much resources your actual applications are consuming at a service level, as well as idle capacity, right? The biggest thing with Kubernetes is that when you're running in Kubernetes, you're essentially reserving capacity. And you always have some room to scale. That's essentially that idle capacity. And there's a cost to that because you're actually running VMs on the background. So somebody has to foot the bill for that cost, essentially. So that's essentially what the aim is here, and that's what the focus is when we talk about these trends, is essentially that prioritization of a spend and how to get more visibility into Kubernetes.
Cool. Thank you very much, Sean. All right, so a little bit more on the trends. As Sean just alluded to, right, no one's going to argue that Kubernetes and containers in particular, the growth it has been and continues to be very, very significant. What you see again here on the right is another snapshot from the 2022 Flexera State of the Cloud report. And what we have seen in the 11 years, one of the many benefits of doing this over the years is that by asking folks, hey, what are you experimenting with? What are you planning to use? We've really been able to see emerging trends on the market maybe before others. So for example, we saw the rise and ultimately I would call it fall, but definitely the stumble of OpenStack. We saw the rise and the plateau of serverless technologies. And for the 11 years we've done this report, the rise of containers has been by far the most significant, and it continues to be such. So what you see here is that, enterprise use of container tools, right? They tend to be using, within the native providers, they tend to be using the tools that are specific to that provider, right? The ECSs and EKSs of the world, Azure Kubernetes Service, you see Google Kubernetes Engine in there. Kubernetes and Docker, obviously the folks that are in their on-premises environments are still tending to use those type of tools. But the point of this is that you can see, between the first two bars on that chart, roughly 75%, roughly 3/4 are either using Kubernetes in some way, shape, or form or planning to, right? So the use of these Kubernetes and Docker and containers in general continues to rise pretty significantly. Now, with that rise, well, what's the problem you're going to have with that? Well, number one challenge that folks have mentioned is lack of internal staff with expertise on containers. And that makes sense, right? You've got folks that know containers really, really well, and that pool is not expanding as quickly as the organizations that are getting into containers. So they're getting stressed and strained to find folks that have experience within containers. If I was a young kid out of college right now, I would be making sure that I would learn as much as I could about container management and container orchestration, because that is going to be a safe job to have for many years to come as more and more organizations start to move into the container world and Kubernetes in particular. Now, we ask folks as well about what are their challenges, if you will, right, and their initiatives and the challenges around cloud consumption in general and containers as well. And optimizing and controlling costs has been the top cloud initiative 6 years running. And you can see there on the right side of the screen, optimizing cloud, and then followed closely by migrating more workloads to the cloud, right? So we have folks that are putting more and more in. As they put more and more in, they're worried about maintaining and optimizing those costs. And obviously, some of the demo that Sean's going to give you is going to talk about how you can do that within the containerized, within the Kubernetes containerized environment. And obviously, as you're putting more and more container-based workloads into the cloud or into whatever environment you're in, that's going to add more complexity to cost management and optimization because, again, you're one level deeper into that tech stack, and the water's gotten a little bit murkier, if you will. So now that we've talked a little bit about the trends, and I kind of alluded to some of the challenges, right? We're going to go ahead and get into some of these challenges. Let me quickly go through those, and I'll pass it. Then we'll pass it to Sean to talk about some of the Kubernetes-specific ones before he gets into his demo. Lack of visibility. You'll hear that as a common theme. You've already heard it once, and it kind of ties into a lot of what we're talking about here. But again, that lack of visibility into what's being spent, who's spending what, and where are they spending it. If I don't have visibility into that, I can't do a lot of this other stuff, right? I don't have the ability to allocate costs, right? Maybe I want to do showback or even better chargeback. I can't do that if I don't know what these different BUs or different cost centers have been spending. If I just get one lump sum bill, I've got 4 cost centers. Do I just give everybody 25% of that bill? Is that fair to the cost center that's doing the right thing? And it's not fair to to them, and the folks that are spending money inefficiently are getting a break where maybe they should. Before I came over to Flexera, I was an analyst over at Gartner, so I talked to folks about this a lot. One of the clients there, he introduced me to this term. I guess it's probably a more common term now, but he called it shameback. He wanted to have the ability to show his cost centers and his business units how much you're spending, sort of in a public forum to kind of shame them into getting their ducks in a row, if you will. So with that lack of visibility, you have the inability to allocate those costs. You can't do that showback, chargeback, or shameback. And along with that, there's not going to be any ownership. If I don't know that I'm spending this much, if I'm not even publicly called out, but if I'm not even publicly aware of these costs that I'm spending, I'm not really necessarily going to be motivated to save because I don't know that, is that on me? I don't know. So there's no ownership if you don't have that visibility. Then going down the bottom row, we talked about over-provisioned resources, right? The whole 4-core versus 1-core thing, right? You really, in the cloud, you're paying for what you got, right? So if you have a 4-core instance, you're going to pay for that 4-core instance, even if you don't need it. We'll talk a little bit here about forgotten resources. This is something we haven't touched on, but is a big, big contributor to the waste that we talked about. A great example is, what dealt with a client many years ago that was launched an M5 4XL in AWS for a few hours to do some dev and test stuff, make sure that they were able to handle what they needed to handle. They ran off to lunch, forgot about it. 29 days later, they get a bill for this thing that's been running for 30 days, and they only needed it for 4 hours. So forgotten resources, right? That's a huge contributor to the waste and the inefficiency that you'll see with regard to your builds in the public cloud. And then I won't get on my soapbox again about paying on-demand prices, but only pay on-demand prices when you have to, right? Again, savings plans you should use. Definitely look into reserved instances. Definitely look into Azure Hybrid Benefit if you're in Azure. If you can use spot instances or low-priority VMs, you can see significant savings. They're not the greatest fit for all workloads, but where they are, super, super effective to save money. And then, sorry, this was supposed to be a hidden slide, so we'll go ahead and pass this one. And I'll pass it over to Sean to talk about the Kubernetes-specific cost challenges.
Perfect. Thanks, Brian. And that infographic that you just shared is actually really has parity with the Kubernetes world. Lack of visibility, the inability to allocate costs, forgotten resources is especially huge. Kubernetes is not easy, right? There's a lot of work there. The engineering teams are concerned about cost, just like the initial shift when people were moving workloads to the cloud. Cost was a second factor, right? The ability to scale, the ability to move was kind of more important. With the adoption of Kubernetes, just like cloud, Kubernetes provides a ton of flexibility with regards to the ability to separate workloads as well as have some semblance of tenancy, whether that be like a managed service provider offering like a container as a service offering, or even just like a large multinational corporation that has a number of different applications that they're running within Kubernetes. Many of the companies we talk to are running multi-tenanted clusters. They see a number of different workloads running on them, including ones that are very dynamic in nature, especially like the ad tech world. They'll be scaling at an exponential rate, adding VMs, adding pods, many seconds over the course of a minute, and scaling at exponential rates. It leads to obviously complex cost visibility challenges, especially when you take into consideration that those workloads can move around, right? A Kubernetes cluster can have node pools that have different sized VMs with different, cores availability and RAM as well as GPU. The less resources that are based on that demand and availability, the way those costs change over time makes it incredibly difficult to track those costs. All right, and I think that's going to kind of bring us to our demo here. So let me go ahead and share my screen.
Please do, Sean. Yep.
Perfect. And while that's coming up, Brian, you talked about kind of your history with Gartner and kind of the different things you've experienced when you're working there. I want to share kind of a story I actually heard the other day, which kind of goes back to the adoption of Kubernetes. Recently, talking to a customer, they say they were actually losing top tech talent because they weren't modernizing their stack. So they were actually running monolithic applications on VMs, and they were losing some of their best engineers because they want to stay relevant. They want to stay current. They see the amazing trends that are happening with Kubernetes, and they want to work with that technology. So we're actually hearing more and more companies moving to Kubernetes because they need to modernize to keep that talent around.
Makes sense, and I've heard the same thing as well. Yep, absolutely.
Yeah. Perfect. So I'll start just quickly with kind of an overview of the Kubecost solution, kind of how we operate. So we are a self-hosted solution. We're going to be operating in your clusters, open core model. We're consuming metrics from the typical Kubernetes metric sources. So your kubestate metrics, node exporter, cAdvisor, and network metric. All those metrics are stored in Prometheus, which we come bundled with. Additionally, we're going to be interacting with the Kubernetes scheduling API. That's going to tell us how long containers have been running over a period of time, and then finally billing data. So by default, we're going to ingest the cloud provider's price sheets, so we know essentially how much those instances cost, and then we will also ingest your cloud bills, just like Flexera does, to ensure that we show an accurate representation of costs based on those different discount mechanisms that Brian mentioned, your savings plans, your RIs, your committed use discount, spot usage, so on and so forth. All right. So that's helpful for teams running a single cluster. Obviously, these large enterprises are going to be running many clusters, whether they be dedicated to different applications, different teams, or environments, right? Like your dev, your staging, your production environments. So we're essentially bringing a single pane of glass that's supported by a bunch of open source technologies. So you heard me mention Prometheus already, and we also bring Thanatos in the picture, which gives us that distributed Prometheus metrics that allows us to have that single pane of glass that allows us to combine your cluster costs as well as your namespace, your pod, your container costs across all those different clusters, giving you that single view into what it actually costs to run an application, not only a production environment, but across your development and staging environments as well. So we take an approach just like a lot of FinOps tools do. So we're focusing on our visibility first. So we're talking about cost allocation. So in the view I'm showing here, this is our standard cost allocation view. You have the ability to look at any period of time you want based on the metrics that we're collecting. So in this example, I'm looking at the month-to-date spend for 3 different clusters that I have spun up across the big 3 cloud providers, so your Azure, your AWS, and your GCP. I'm currently aggregating my cluster just to show you that we are bringing in different metrics from different clusters into this view. So you can see I've got my staging environment, my production environment, as well as my development environment. Now, important to note that we do operate throughout the Kubernetes cluster. So you can show your costs at kind of any level within that Kubernetes hierarchy. So right now I'm showing it at the cluster level, but I can very simply change to another view, and now I'm looking at my namespaces. What's unique about this view is I'm not currently filtering by clusters, so I'm actually showing the cost for these 2 namespaces across all the clusters that are reporting into Kubecost. So I can see that total cost of ownership for this particular applications. Now, you may have noticed multiple columns here. So we're not telling you just what your application costs or what your services cost to run in Kubernetes. We're telling you what each piece of the application costs. So there's 3 different categories of costs. These first 6 columns here are specific to the in-cluster spend. So that's the actual compute resource that you're consuming. So your CPU, your GPU if you're using it, RAM, storage, network, load balancers. External costs, this is a great tool for those applications that are consuming cloud native resources outside of Kubernetes. So maybe you've got a microservice application that is consuming Amazon RDS or running some Lambda jobs as part of a serverless function. You can actually tag those resources in the cloud provider, and then when we ingest that cloud provider's bill, we will automatically allocate those costs to the different Kubernetes tenants that are consuming them. And then finally, there's shared costs, right? Shared costs are especially important in a chargeback, or as Brian called it, shame back or blame back type of scenario. So shared costs allow you to kind of allocate different costs throughout the cluster and even outside of the cluster back to the different teams within. So shared overhead allows you to add a fixed monthly fee on top of your cluster costs. Think of this as a really good way to add like an operational cost, right? Maybe you've got an SRE or operations team that's supporting the scaling of the cluster. You can add a fee essentially for that management of that cluster for them, or maybe even a licensed piece of software. It's not unheard of to run, a fairly expensive piece of software within the cluster that all the different tenants are consuming. You can add that license fee here, and we'll proportionally distribute that cost to the different tenants. Shared tenancy costs. The cloud providers are offering these managed Kubernetes services that make it much easier to consume Kubernetes, so you don't have to worry about the control plane. But obviously, they want their piece of the pie, right? They're going to charge you for operating that managed Kubernetes offering. I believe AWS and GCP do today. I think Azure does not for the lower availability tier, but if you go to the higher availability tier, they do charge for that. So we can essentially flip this switch, and then we'll take that cluster management fee, usually it's something like 10 cents an hour or something like that, and then charge it back to the tenants as well. Shared namespaces and shared labels are a great way to share the cost of resources running within the cluster. In a multi-tenanted world, you're probably going to have services running within cluster that all the different tenants are consuming. I have Kube system here as a great example. The underlying running of the cluster. Great examples would be something like observability stack. If you're running like a Prometheus, Grafana stack to do observability of the different metrics within your cluster, logging, data science, even security if you have like ongoing vulnerability scanning or some type of policy management within a cluster, some things like that. And that can be done based on namespaces or even labels. So if you kind of have those split out across different namespaces or across those different hierarchies, you can do it either way. Now, by default, we're going to proportionally split these costs based on spend. So what I mean by that is, let's say that this Acme Fitness namespace is responsible for, 30% of the spend within cluster. That same namespace, as example, is also going to be responsible for 30% of that shared cost as well. Now, we are looking at namespace. This is probably the most common tenancy model we hear about Kubernetes. It's great from a logical standpoint of grouping different application components together. But we can also look at costs throughout the hierarchy. Different teams may want to look at based on a label or maybe down to like a job or even like a deployment level. So we can kind of mash up that data however it makes sense for the different organizations that want to do that chargeback within Kubernetes. Now, you heard me mention the idle component a few slides back. So right now, I'm hiding that idle component. So right now, I'm going to separate it out. So essentially, what we're defining as idle here is essentially the slack capacity within the cluster. So that's basically the difference between request and usage and provision capacity. There's a cost to that. So the question is what to do with that cost. In a showback type scenario, typically it's just good to have visibility to it, right? How much waste or how much room to scale do we have in that cluster? Whereas in a chargeback type of scenario, you want to be operating at net zero, right? You don't want to be responsible for those costs from like a shared IT perspective. So we do allow the ability to share those costs. So when you do share those costs, it's doing the same thing as that shared component. It's doing a proportional distribution of that idle capacity back to the different tenants that are consuming Kubernetes. So let's take this opportunity to drill down a bit. So because we do operate throughout the cluster, we can show you costs all throughout the hierarchy. So if I pick this Acme Fitness as an example, you see I've got a number of different deployments supporting my application running here. If I pick like my catalog or my front end, I'm now looking at the different pods that are within that particular deployment. And then finally, when I click on a pod, now I'm looking at the actual containers. So this is where the Kubecost cost model is running to allocate those different costs to the resource run within Kubernetes. So we're using 3 sources of information for this. The first is going to be those metrics we're collecting. So your cAdvisor, your node exporter, your KSM metrics. This is telling us essentially how much resources are being consumed. The second is that Kubernetes API, so to determine how long this container is running for. So you say, 396 hours based on my month-to-date query. And the final is that billing data. So pulling in the on-demand rates, or if you are running, RI savings plans, spot, or those other discount mechanisms, you'll see an adjustment as denoted here by this column here. And then we're taking all the information to determine the cost. So the really neat way about the way we do this, and especially with regards to Kubernetes, is when you deploy an application to Kubernetes, you typically are defining resource requests, right? My application needs 1 CPU, or my application needs 1.5 gigabytes of RAM. But just because you're requesting that does not mean you're consuming that. Kubernetes is going to set aside and those resources to support that container to ensure it can be scheduled properly within a node, but it can definitely be running under or even over those provisioned resources. So what we're doing is we're looking at the usage over time. So you can see this front-end container is using a fraction of the 1 core that I just mentioned, as well as well under a gig of RAM. So in this example, we're actually going to charge or allocate the cost based on the request sizes. So that 1 core, that 1 gig of RAM, that's what essentially we're going to base the cost on. Now, in an example where this application is scaling, you'll say, we're running a large sale. We have a big influx of traffic on the site. Now the front end is scaling up and above the requested resources, operating somewhere between requested resources and limits. Let's say it's consuming 1.5 cores and 1.5 gigs of RAM. Now we're actually going to switch to calculating that cost based on the actual consumption, the actual resources that are being consumed. So the takeaway there, especially from a chargeback perspective, is that different teams are always going to be charged based on the higher of those 2 values with regards to requests and actual usage, and then the rest of that is essentially that idle capacity that we're touching on. Things like storage, load balancer, networking, those are always going to be charged at the actual consumption rate because you're not essentially setting requests aside for those. Now, you may have noticed the Open Grafana button down here. So we do ship with Prometheus. We do ship with Grafana as well. And what this allows you to do is to break out to, an observability dashboard to get more historical information. So you can kind of see the trend and analyze that usage over time. And this will help you kind of identify, well, is my container sized appropriately? Do I see any spikes in traffic? Is there anything I need to be aware of? What this also points out is that Kubecost is essentially storing its data in a Prometheus data source. So if you guys are already running observability platforms, you can essentially add that Kubecost data source as an additional data source to them and bring in that rich cost information to your existing operational dashboards. All right. So the last piece I want to highlight here is this efficiency column, and for that I'm actually going to jump back to my save view. I like doing this at the namespace level. So what efficiency is telling us is essentially it's a high-level measurement of how efficiently a resource is consuming the requested capacity within the cluster, right? So typically you want to see a little bit higher efficiency. Sometimes you'll see over 100%, and that's essentially signifying that you are under provisioned. You're essentially using more resources than you have initially requested. But this is a great metric for teams to consume to understand how efficiently sized their applications are. And that kind of leads us to the next piece we want to talk about, which is cost optimization or cost savings. So using all these metrics that we're pulling in, we have the ability to surface some potential cost savings opportunities. Now, there's a number of different ones here. I'm only going to touch on a few, kind of the ones that I feel are the most important and the ones we get the best feedback on. So in a Kubernetes world, you typically start optimization at the lowest level. And that's basically right-sizing your container requests. In talking with a lot of different companies, the majority of companies, when they do deployments, they're either enforcing setting requests at deployment time, or they have some type of process to review them after a while. So what we're doing is we're taking all these metrics we're collecting, we're looking at the historical usage of those resources for a particular container, and then based on that and the efficiency score we're targeting, we're surfacing recommendations on what Kubecost believes those request sizes should be. So using the example of something like, let's see, the cost model container for Kubecost, we can see that this particular container has run in 2 separate instances over the past few days. You can see I've actually got 2 different peak usages here, so just under 16 millicores as well as just under 7 millicores. So based on that, we're going to take the higher of the 2 values. So we're basing these recommendations on that peak historical usage. And then the request size is currently 200 millicPU. So you can see we're consuming a fraction of their requested capacity. So based on that, Kubecost is actually going to recommend resizing that request size down to 25 millicPU. Now, the memory is a different story. You can see that we're actually requesting only 55 megs of RAM, but we're actually consuming much more than that. So we're a bit under provisioned there. So we're consuming 360 megs of RAM. So based on that and the efficiency we're targeting, we're actually going to recommend upsizing that memory request to 556 megs of RAM. This is going to ensure that container can remain running and be able to be scheduled in different nodes we have within our cluster. Now, you may have noticed this little yellow triangle here. So this is essentially highlighting that piece I just pointed out to you, which is that you may be under-provisioned. In the Kubernetes world, it's fairly common that application developers will deploy the containers without having any knowledge of what resources they do need. So this is a really important report for them. So they can essentially, after they do that initial deploy, they come back here, they can analyze their usage, and then they can make adjustments to kind of better suit the actual capacity that they require. Now, something I haven't touched on yet is that everything in Kubecost is programmatically accessible, so we do expose APIs for all the different cost allocations and savings views. And you can kind of let your mind wander there and make some assumptions of what's possible. But we have a number of teams today that are using specifically this container right size report directly in their CI/CD pipelines. And what that's allowing them to do is, typically one of 2 things. One, just being a check as part of like a pull request saying like, is the application developer requesting a responsible amount of resources, right? Or is it like, 10x what Kubecost is recommending? Or for the teams that have embraced, more of an automated DevOps tool chain, you can actually use this data source to dynamically set those request sizes at provisioning time. Now, kind of talking about that wasteful spend, like Brian was saying, one of the big things with cloud is turning things on and forgetting to turn things off. That obviously happens in Kubernetes as well. We typically see this in development workloads. So we developed this abandoned workloads report. And the concept here is that if an application is running within Kubernetes and it's not consuming a specific rate of traffic, the idea is that workload may no longer be required, right? If it's not doing anything, it requires some additional investigation to determine if it can be removed. So we can define the threshold here as well as a period of time to analyze over, and then we'll surface any pods that are not exceeding that rate of traffic. So we've right-sized the containers. We've eliminated waste by removing pods that are no longer required from the clusters. Typically what we see now is that idle category, that idle capacity of the cluster has grown significantly, right? Because we've reduced waste and we've typically reduced our request sizes as well. So the next logical step here is to actually right-size your cluster. So based on all those different metrics we're collecting, as well as the right size of different containers, eliminating waste, we're going to surface some recommendations for the node pools that you should be running within your cluster, based on more tightly packing those applications to get more efficient usage of those cluster nodes. So a simple recommendation might include like a single node group with a handful of instances of the same size, whereas a more complex recommendation will have a few different node pools of different instance sizes to better support more tightly packing of those applications. Now, there are a number of different opportunities here, and in the interest of time, I'm not going to cover them right now, but we do have a robust documentation set that kind of goes through the different details we provide within these reports. One of the last things I want to cover is alerting and notifications, right? What good is a tool that provides you the visibility as well as the potential savings opportunities if you're not getting notified about them? So just like Flexera, and I'll show you that briefly here as I switch in a moment, we have the ability to define a number of different alerts. So a budget alert, especially in a chargeback model, if you have different teams that have a well-defined budget for their application cost of running Kubernetes, you can define a aggregation to use, whether it be namespace, label, pod, or even just at the cluster level. And then if that budget is exceeded, you can choose to get an email, or optionally, we hook up with a Slack webhook to post within a Slack channel as well. The next would be an efficiency-based alert. So that's based on that efficiency percentage, that efficiency threshold. So basically, same aggregation, whether it be namespace, label, so on and so forth. You can define a filter. So if you want it to be, a broad or a granular set of resources, and then if that efficiency threshold, if the efficiency drops below that threshold, you can get a notification. And then optionally, we do have the ability to specify a cost threshold. So you're not essentially getting, notifications for when there's like a $5 change. Reoccurring updates. So think of this like a scheduled report. So basically like a high-level overview of what your spend is based on namespace, label, pod, cluster over a period of time sent to the same email and Slack channel. And then finally, spend change, or more commonly referred to as cost anomaly detection. So taking the running rate of the historical average of your resources as well as a relative spend change threshold, and if the spend changes above or below that percentage, getting a notification based on that spend change. All right, so now that we've got all this information, we're calculating the cost for all of the resources running within Kubernetes. And now we essentially want to mash up that data with our generic cloud cost bills, right? So this is where I'm going to switch over to Flexera and talk about their solution a bit. For those that don't know, Flexera offers a world-class SaaS platform called Flexera One. There's a number of different capabilities they offer. We're going to be focusing primarily on the cloud cost optimization piece here. And for that, they allow you the ability to ingest your cloud provider bills, so your AWS, your Azure, GCP, but they also allow the ingestion of third-party bills. That's kind of where this integration comes in. So you can see this high-level chart here. I've got my costs for AWS, GCP, as well as Azure coming in, but I also have this green bar here specific to my Kubecost. So Flexera is essentially interfacing with the Kubecost cost allocation API to pull in this data on a daily basis and bring it in line with the rest of the cloud costs that the platform is ingesting. Now, they have a number of different opportunities, a number of different ways to kind of show this data and make it visible. And really the key concept here is what they call a billing center. So think of a billing center as a cost allocation bucket where you can define a set of rules to bring in costs from different cloud providers, either based on accounts, the cloud, the tags, or the resources that are being consumed within those. And then you can essentially define a hierarchy of billing centers that allow you to essentially rebuild that cost center structure that you have internally in your business, so that different teams can come in here and get visibility to their costs based on those set of rules that we have. Now, I've set up a few example billing centers here. I've got my central IT bucket where I'm dumping my costs for most of my cloud bills. So I got my AWS, my GCP, my Azure in there. I've got my data science bucket that's got some of the workloads I'm running in Google. And then finally, I've got my engineering teams, right? These are the teams that are consuming Kubernetes that need to have visibility into the cost of those resources. So if I click into this bucket, now I'm presented with a simple dashboard that shows my spend for Kubernetes. Great, high level, right? Well, I can switch to namespace view, and now I'm seeing the costs for those two separate namespaces that I was highlighting in Kubecost directly in the Flexera One platform. Simple high-level view, show my cost over time for my entire engineering team. But because billing centers do have a hierarchy to them, I can switch down to my billing centers view within engineering. You can see I've got two development teams defined here. The Acme Fitness application as well as my dev team B. So by going into Acme Fitness, I'm now able to look at the cost specific to running my application across all those different environments. And again, I'm just looking at the high-level cost right now, just the cost for Acme Fitness in general. But because they offer a number of different dimensions to show this data by, I can easily switch to see, well, here's my running cost for each one of those namespaces across those different clusters. So I can see that Stage is actually my most expensive cluster to run this application in, whereas Dev and Prod are significantly less money. But if you want to, you can actually go to this tabular view and you can get much more granular with how you're showing those costs. So right now, I'm showing those same three clusters. But let's say I want to look at specifically what the cost is to actually run those resources within those clusters based on the type of resources I'm consuming. So that's specific to whether it's more of a CPU resource intensive application or more memory intensive. So let me go ahead and switch my view here from daily, and we'll look at the last essentially 2 weeks worth of data. And you can see I can actually look at my CPU usage versus my GPU, my load balance, my network, even my shared costs kind of over time, and see how those costs trend and add up for each one of those different components. So super high level visibility for the different folks maybe in finance that want to do chargeback and tell each team, what they're responsible for with regards to their cloud bill and Kubernetes bill, as well as giving the engineering teams access to that low level information to better understand what it costs to run an application based on the different resources that it's consuming. Now, it doesn't just stop there. Obviously, Flexera does a really great job with the ability to show you the cost based on the different cost centers. But what they also have is this great feature called automation catalog. So think of this as ongoing automated governance. Now, a lot of this catalog has, last time I counted, probably over 150, close to 200 different policies that allow you to do things like look at tag compliance, look at unattached volumes, unused clusters. But of course, we're here to talk about Kubecost. So if you search for Kubecost, we actually have 2 different policies here that specifically consume our APIs for those request sizing recommendations that I just touched on previously. So I do have these runnings to kind of show you what that data looks like. So if we switch to the applied policies view, we can actually see that we have that same request sizing recommendations running in here, just ran the other day. I have it running once a week. I also have it sending me an email to make me aware of the different cost savings opportunities that are available. And when I click on this incident report, I get this nice table that allows me to filter and show all those different applications based on a container level and those same usage and request metrics and what the recommendation is from a Kubecost perspective. Now, one of the great things that Flexera adds here is that their policies are not just for reporting. They do have the ability to take action. And with that, their robust cloud workflow framework allows you to essentially define a set of steps to take if something is defined as out of compliance. So you could actually use Flexera directly to resize these resources as well, or even just arrange notifications for different teams within different channels within your messaging platform. All right, and I believe that will conclude the demo for today. I think we're right on time here, so I'm going to go ahead and hand it back over to you, Brian.
Thank you very much, Sean. I appreciate that very much, and you did a great job as usual, digging into the details of the integration between the 2 platforms. And as many times as I see that demo, I'm still impressed each time. So thank you very much.
Sure thing. Happy to help.
All right, so I know it's a cliche, folks, right? But you see there on the screen the whole better together, but it really is true. And we'll talk a little bit about that before we kind of get to the summary, and then we'll have time for some questions here at the end. But both the Flexera One platform as well as the Kubecost solution are built API first. Basically, everything you saw happening through the user interface is the user interface making an API call to the back end to extract that data. So that allows these deep integrations like the one that Sean showed you with regards to the billing centers and the common bill ingest and that kind of stuff. Through that integration, you get that holistic view, right? You get that view of from the top down, right? You get the view of not just your VMs and your network and your storage, but you can also, obviously, as Sean showed, drill down into, into each of the individual containers, or at the cluster level, the namespace level, et cetera, as well. What this gives you, right? We talked about before, that lack of visibility. You don't have the ability to allocate costs. Well, now you have the ability to allocate costs. You can see who's spending what, where they're spending it, right? And so you can go ahead and allocate those costs in that showback or even chargeback method that we talked about before. And then as also, as Sean showed, there's the ability to automate recommendations for cost optimization. So not only, are we going to give you recommendations, you can automate that. You come back and make, decision whether you want to pull the trigger on those individual ones or not is up to you, but continually making those recommendations where you can effectively save some more money as you go through. So in summary, and then I'll pass it over to EJ here in just a minute to ask any questions that have come in. But as we talked about early on in the discussion, cloud consumption continues to increase, right? We saw it increasing in the enterprise space. We saw it increasing considerably in the small to mid-sized businesses space. I think we're going to continue to see that grow. I'm really curious to see the 12th edition of the State of the Cloud report next year, where the SMB spend is, because that has been trending up. And like I said, this year was a huge jump over year from last year. Containers and use of Kubernetes in particular to orchestrate that is also accelerating, right? I mean, we've seen that through the State of the Cloud report. We've seen that through our clients. We've seen that through industry analysis. Containers and Kubernetes in particular, Kubernetes is the 800-pound gorilla in the container management space. That just continues to accelerate. And as Sean alluded to, and I mentioned and he alluded to, is that the cost challenges are going to be kind of the same thing, regardless of how you're doing things, right? Whether you're just running in the cloud straight up, you did a lift and shift, a rehost, whatever you want to call it. You've broken your things into microservices, you're using containers, whatever the case may be. You can still forget about things. You can still over-provision things, right? The problems are the same. And then through the demo, he showed that Flexera 1 CCO, or Cloud Cost Optimization, in combination with the Kubecost solution here, really gives you that visibility, right? It boils down initially to visibility. You need to see, I think it was Deming or whoever, the business guy back in the day, right? You can't manage what you can't measure or whatever, right? So we're measuring, right? We're giving that visibility. Gives you the ability to do cost tracking, see where those costs are going, gives you the cost optimization, including the automated cost optimization recommendation, into all your resources, right, regardless of where they are in that stack, whether they're at the VM level or whether they're all the way down to the container level as well. Sean, anything to add in there before we jump over to Q&A?
Yeah, I mean, just kind of reiterate, because cloud Kubernetes adoption continues to grow, it's only going to get more and more complex. I mean, we used to joke that every year AWS reInvent, they'd announce like 100 different services. And it would just be continue to offer these new offerings that developers want to ingest, they want to use, they want to leverage, because in the end, it makes their life easier. What it does is it makes the ability to charge back and make each team responsible for costs infinitely more difficult. And that's kind of where Kubecost and Flexera come in to help solve that problem.
Yep, great point. Great point. So I'm actually going to ask EJ to jump on the line, who's been running the man behind the curtain there, and see if any questions have come in from the audience. We can go ahead and answer those. EJ, do you have anything for us?
Yeah, Brian, we got just a few questions here. And it looks like the first one here, they've got an existing stack, so they're asking, do you integrate with our existing observability stack?
Okay, so got it. Oh, well, I'm going to pass this one off to Sean. The U there, I think, is Kubecost. So, yeah, Sean, do you integrate with their existing observability stack?
Yeah, that's a great question. That's kind of what the core focus of our open core model is. We not only provide an open source version of our product, but we also leverage kind of the de facto standards within the CNCF cloud native open source ecosystem. So we use Prometheus as our default backend storage, and we do come bundled with it. We use Helm v3 as our default deployment mechanism, which automatically deploys all the dependencies we need to operate properly. Deploys in less than 5 minutes. But a number of these large enterprises, or even smaller enterprises, already have existing like Prometheus, Grafana, or additional data and observability tools that they want to essentially plug us into. So we're definitely open to do that. We have a number of different customers today that are using things like Amazon Managed Prometheus, Grafana Cloud, even Victoria Metrics as a backend database for that. So yes, as long as typically we say as long as there's a problem kill endpoint, we can usually integrate that to store our metrics and consume the data from.
Cool. Thank you, Sean. EJ, anything else?
Yeah, we've got another one here. Do you support Kubernetes clusters without direct internet access?
Obviously, I'm going to pass one. I know the answer to this one, but it's a great answer, so I'll let Sean answer this one. Yes, please.
Yeah, this is actually kind of one of the big differentiators between us and a lot of our competitors in the market is that because we are a self-hosted solution, we have no direct dependency on internet access. So as long as it's a Kubernetes distribution, we can operate in the cloud, on-prem, at the edge, or even in air-gap networks. We have a lot of three-letter agencies that rely on us for cost introspection within the Kubernetes world.
Great, thank you, Sean. EJ, we got anything else coming in?
Sure, looks like at least two more here. So the next one, do you accept pull requests?
That's always a great question for an open source based product, right? Yes, we are happy to source a pull request for our products. Like most companies that talk about their open source model, we've got over 2,000 stars in GitHub, very active, and we do commonly receive pull requests for additional functionality from the open source community.
Great,
awesome.
Thank you.
All right, and the next one here, my company uses business intelligence tools to create cost management reports. Can Kubecost integrate into such tools?
Yeah, I can actually see this as being both Flexera and a Kubecost question, and the answer is yes, right? Because both tools offer a robust API to extract that information. You can very easily incorporate the data into any existing BI or visibility tools that you have, whether it be at the finance level or the engineering level. And just kind of reiterate from the Kubecost perspective, not only do we expose a simple UI to get our information as well as the API, but because we are backed by Prometheus, that provides a really easy mechanism to incorporate our metrics into existing operational dashboards that different engineering operations and SRE teams might be using.
Awesome. Thank you, Sean. EJ, anything else? You mentioned two more. That was two. Do we have anything else? We're good.
Does not look like we have any more questions coming in at this time.
All right, cool. Well, then I will give you guys, well, folks there, 6 or 7 minutes of your day back. I want to thank Sean very much for taking the time to join us. EJ, thanks for always running things behind the scenes so seamlessly. And we'll say thank you to everybody else out there for joining us. Appreciate it. And Sean, I'll give you a chance to shout out as well.
Yeah, always a pleasure. Really appreciate the time, Brian, and thank you to Flexera for hosting us as well.
All right. Thank you, everyone. Have a great day.